Hello and welcome. Today we're going to be looking at the SAT Math full test. This video is the non-calculator portion and the next video is the calculator portion. Here we're going to be looking at every single question on this entire test and figuring out how to do it and what concepts are used in solving this problem. Every single problem is going to be solved. Here we go. If you like these videos or find them informative, please be sure to like and subscribe. And with that, let's get started on our first question. Alright, so the SAT Math non-calculator section has 20 questions that are going to be done in 25 minutes. So we're going to go by 5 questions at a time. The answers are going to be listed here if you want to look at them. But we're going to start with question number 1. Here we go. Alright, so question number 1. What do we see? We see if x minus 1 over 3 equals k, and k equals 3, what is the value of x? So if x minus 1 over 3 is k, right, so this is the first statement, and the second statement is just that k equals 3. Right, so it's a pretty simple problem, right? You have k equals 3 here, so you can just plug this in, right? Directly plug it in, you get 3, multiplied by 3 on both sides, times 3, times 3, you get that x minus 1 equals 9. You add the 1 to both sides, and x is 10. Alright, so x equals 10 is our answer here. X equals 10 is choice D. So we're just going to write here 1 is choice D. You can see number 1 is choice D, and we can move on to question number 2. Alright, so we're going to go to question number 2. Let's scroll down to that. Alright, so now we're told for I equals the square root of negative 1, what is the sum 7 plus 3i plus negative 8 plus 9i? Okay, so 7 plus 3i, and we're supposed to be adding that to negative 8 plus 9i. So now, the only really scary thing about this problem is that they told us that I equals square root of negative 1, right? But you don't have to think about it in terms of that. You can think of this as like a variable. And instead of thinking about this as an I, let's think about this as x. Let's make this x, right? So 7 plus 3x and negative 8 plus 9x. Then we just add it together, right? You add the x's and you add the constants. Negative 7 and positive 7 and negative 8 is negative 1. 3 and 9 is 12. Negative 1 plus 12x. Since we put x as I, we're just going to have to substitute that in. Negative 1 plus 12i. Negative 1 plus 12i, that's choice A. So question number 2, choice A, and we are done. Alright, so let's move on to question number 3. Here we are. Alright, so we're told that on a Saturday afternoon, Armand sent M text messages. So M text messages. So M texts each hour. So M texts per hour. Right? You can think of it like that. He sent M texts in 1 hour, so it's M texts per hour. For 5 hours. And Tyrone, he's sending P texts, text per hour, the text per hour for 4 hours, and we want to find the total number of messages that were sent on that Saturday afternoon when this happened. Well, let's see. M text per hour, and we have for 5 hours. Let's see. So here we have an hour in the denominator and an hour in the numerator. So we can cancel these out by multiplying them. If we do M text per hour for 5 hours, we multiply these two together, we get 5M texts, right? The hour here cancels with the hour here, 5M texts. That's it. And then for this one, the hours here cancel out when you multiply these two. This is going to be plus 4P. So the total number of text messages that were sent that afternoon, 5M plus 4P, that's just answer choice C. And we can keep going to the next question. All right. Next question, number 4. Let's scroll down to that. Right, so this one seems to be one of those. It's not just computation anymore. Trying to interpret something. All right, so question number 4. What do we have for question number 4? All right, so question number 4 says Kathy is a repair technician for a phone company. Each week, she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P equals 108 minus 23D, where P is the number of phones left, and D is the number of days she has worked that week. What is the meaning of 108 in this equation? See, let's think about this, all right? So we're told that the number of phones that she has left to fix, is it can be represented as P equals 108 minus 23D. And we want to figure out in this equation, right, what does this number right here mean? What does this mean? What does that mean? Right? Why is that there? Right? What would be changed if we put a different number there? If we put like 109, 110, what would be changed? So we can think that, like, let's see what we can do, right? So we know that this is the number of phones. P here is the number of phones. Okay. So we can see, right? We can see pretty clearly that if we just take D and make it 0, we just make this 0. If we make this 0, then this whole thing cancels out, right? If that's 0, so after 0 days, this cancels out, and we're left with number of phones is 108. So what that means is that at 0 days, at the very beginning, she had 108 phones to fix. So she started with 108 phones to fix. And we see that in choice B. Kathy starts each week with 108 phones to fix. So B is our answer. Choice B. And we can move on to the next question. Alright, next question. I have to scroll a bit down to get there. Alright, so next question we are given as, what are we given as? 5. X squared y minus 3y squared minus 3y squared plus 5xy squared plus 5xy squared minus negative x squared y plus 3xy squared minus 3y squared. Right, so this is the equation. Right? We're given x squared y minus 3y squared plus 5xy squared minus, in parentheses, negative x squared y plus 3xy squared minus 3y squared. And we're asked, which of the following is equivalent to this expression, this whole thing? So essentially, it just wants to simplify this. Right? We simplify this, we are done. Let's do that. So, how are we going to go across doing this? So one thing I want to notice, first of all, is that we have 3 terms here, right? Now, three kind of groups of terms, right? So here, these two are the same group of terms, right? Because they're both an x squared y. And then you have some coefficient, like 1 or negative 1. So it's the same group. So we can, like, add these or subtract these together because they're the same group. And then these two, they're both a 3y squared, so you can do, you're going to subtract these two. And then these two are also both xy squared, so we're going to do these. You can't, like, subtract this from that because they're different groups, right? This has an x and that doesn't, so you can't do it. These have the same variables, so that's why you can do it. These have the same variables, so you can do that. You need to match that up. All right, so we have enough talking. We have x squared y minus negative x squared y. So let's see how we're going to do this, right? So we have a negative here. We can distribute the negative through everything. So we can get rid of this negative sign, but we have to multiply everything on here by negative 1. So this becomes a positive, this becomes a negative, and this becomes a positive. So it's a this plus that. Alright, so x squared y plus x squared y is going to be 2x squared y. And then the negative 3y squared plus a 3y squared is going to cancel out. It's just going to become 0. And then you have 5xy squared minus 3xy squared is going to be plus 2xy squared. So our answer here is 2x squared y plus 2xy squared, which is going to be choice C. B is choice C. And we can move on to the next question. Let's scroll down to 6. Okay, question number 6. Alright, question number 6. We are given h equals 3a plus 28.6. H equals 3a plus 28.6. H equals 3a plus 28.6. A pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age a in years between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? Alright, so every year, what are you going to do? So this is just a constant, right? So when he's 2 years old, or just when he's born, right? In terms of the boy's age. So when he's 0 years old, when this is 0, he just starts at 28.6. So he's 28.6 inches to begin with. That's what he started at. And then every single year, if you add one extra year, what are you gonna do? Well, we can model it like this. So let's not put an equal sign. Oh, we had 3, and then we're not multiplying it by a, because a was his age now. I'm looking at his age the next year. So the next year is just going to be a plus 1, right? So we put a plus 1, and then we add the 28.6. So if we just figure this out, then we have 3a plus 28.6 plus an extra 3, which is just this plus 3. So if you go one extra year, you just added 3. Which, if you think about it, this makes sense. This is what this thing right here, this coefficient of a, that is what that means, right? If you have a slope here, the slope here, that means that if you go one unit in the x direction, like in the age in this variable, you are going to go up by this much in the y direction, which is the height. If you go one unit up in age in a, you're going to go 3 units up in h, because that's the coefficient. You didn't have to do this, but this is what we did. This is just a short proof of why this works, how that works, and our answer is just this coefficient right here. It is 3, or choice A. So let's erase this. And question number 6, the answer is A. And we can move on to question number 7. All right, question number 7. Oh, that's a big question. Okay, question number 7. Right there. Okay. Question number 7, as you can see, is it's this one, by the way, like the one that has m equals r over 1200. I'm pretty sure you know that because we just see the other ones, but this is our question. It seems fairly complicated, but let's read through it. All right, so I'm not going to write the equation out to begin with. I'm just going to read it first and then figure out, do I need to write the equation or what's going on? So the formula above gives the monthly payment m needed to pay off a loan of p dollars at r% annual interest over n months. The following gives p in terms of m, r, and n. Okay, so this looks really scary, right? I won't deny that. Right? If you look at this, your first thought is, what the heck is going on? Right? So this obviously looks very scary, but if we just step back a moment and look at this, right? So let's say m is equal, or no, m is equal to, let's assign the variable a to the numerator and a b to the denominator. So you have that a here is going to equal that r over 1200 plus 1 plus r over 1200 to the n, and then b here is going to equal the 1 plus r over 1200 to the n minus 1. So that's what a and b is, and then you just have the p. And they're asking us to solve for p in terms of everything else. So if you look at this, it looks pretty easy now, right? You multiply by b on both sides, and you get bm equals ap. And then you just divide by a on both sides, and you get b over a is just ap. It's just p. So this is literally it. Right now we just we know how to write p in terms of everything else. So now we know that p is going to be this m times b over a. And we know what b and a is because a is going to be that numerator and b is the denominator. So we literally just flipped it. So this right here is going to be m times denominator, which was this up here to be the denominator of the original one. So m times 1 plus r over 1200 to the n minus 1 over r over 1200 times 1 plus r over 1200 to the n. So that fraction that we see, that standard fraction in the original problem, we flip it and then times b times m. And we see that in choice B, we see that. We see p equals the denominator of the original over the numerator of the original times m. So our answer is just choice B. Right, so our answer is choice B. Choice B. And we can move on to question number 8. Alright, question number 8. Nice change of pace after all those fractions and stuff. Alright, so if a over b equals 2, a over b equals 2, and they want us to find 4b over a. Okay. So there are a number of different ways to think about this problem. Right, the way I would probably do it, just to be as quick as possible, is thinking that if a over b is 2, I can flip that and get b over a is going to be the reciprocal of 2, which is just going to be 1/2. Right, this makes sense, right? This inherently just, you should understand what this is, right? If you multiply these two, a over b and b over a, you get 1. And if you multiply these two, it's also going to be 1, so they're equal. Right, because if you multiply them, you get an equation that is actually true. Right, so if a over b is 2, you flip it, you get b over a is 1/2. And then you just multiply this by 4, so times 4 times 4, and you get this 4b over a equals 4 times 1/2. And that's just going to give you 2. So our answer is going to be 2. 8 is choice C. Now, I do want to say, if you don't see this approach of just flipping the fraction, right, don't worry, because there are many other ways to solve this. And I think the main way you solve this otherwise is saying a over b is 2, so I can multiply by b on both sides and get a is 2b. A is 2b. Alright? Now where I see 4b over a, I can make that 4b, and then a is 2b, so this is just 4b over 2b. And then the b's cancel out, and 4 over 2 is 2. So you end up with the same thing. It's still c. Right, so the quicker way is to notice that you can flip it and then just multiply by 4. The slower way is to write a in terms of b and then plug it in. Right, both of these ways work, both these ways are valid, and we still get the same answer 2, answer choice C. Let's keep going. Okay. Question number 9 is next. Let's scroll down to there. Okay, so we get 3x plus 4y. 3x plus 4y equals 23. So you can negative 23. 3x plus 4y equals negative 23. My bad. And then 2y minus x. I'm going to write that as minus x plus 2y. Right? It's the same thing. I just switched the order. Because up here we wrote x and then y, and I'm trying to keep that the same because it just makes it easier to look at. And then that equals negative 19. Okay. So what we're going to do here. We're trying to find the solution of systems of equations. So as you know, there are two ways to solve a system of equations. You can use substitution or you can use elimination. If you're to use elimination, which personally is my favorite way to do any system of equations because it's just faster in general, you have two options. You can multiply this by 3, this bottom one by 3, and add them up, and you get so if you multiply this one by 3, you'd get negative 3x plus 6y equals negative 57, and then these would cancel, and this would make 10y, and this would equal negative 80, so you'd have y equals negative 8, and you'd get, what would you get? You'd get, x is 3. X is 3. Right? So you'd, yeah, that makes sense. y is negative 8, x is 3. Now, the other way you could use elimination here is you could multiply this by 2, this bottom one by 2, negative 2x plus 4y equals negative 38. And then do this one minus this one. And that way you do that minus that, would give you 5x. This minus this would cancel out, and then that minus that would give you 15. So you get x equals 3, and you get y equals negative 8, same as before. Alright, so that's elimination, right? As I said, elimination, it just works better in a lot more situations. So it's usually better to look at that first, right? So I would use elimination, but obviously you can still use substitution. So you can use substitution. Now the substitution is a bit nice here because they already gave us an x by itself. So you just add the x to both sides, and you get 2y equals x minus 19. And then you add the 19 to both sides, and you get 19 plus 2y equals x. And then you just take this and stick it in here. So you get 3 times 2x, why did I say x? 2y plus 19 plus 4y, and that's supposed to equal negative 23. Alright, so this is going to give you 6y plus 57 equals 4y equals negative 23. This is going to become 10y. This is, you subtract 57, it's going to become negative 80. Y equals negative 8. Again, and then you can solve and get x is 3. So our answer is 3, negative 8. That is choice B. So with systems of equations, there's always going to be lots of different ways to do the question. As I said, you should just do elimination. It's just a lot faster. If they do give you something that's particularly nice for substitution, like it's alone and there's like no constant or something, then you can try. But elimination is tried and true. It works every time and with basically no mess. So yeah, I would say use elimination. It's faster. So yeah. Okay, I did not mean to drop that. Anyway, question. Wait, we just skipped question number 10. Question number 10, sorry, is down here. That threw me for a loop. Okay, so g of x is going to be ax squared plus 24. Ax squared plus 24. And g of 4 equals 8. Okay, so I plug g of 4 in. Then I get 4 squared, so that's just going to be 16a plus 24, which is going to equal 8. And then you can find that a is negative 1. Right, and then if you plug in g of negative 4 into a is negative 1, so that's going to be negative x squared plus 24. X squared is negative 4 squared is going to be 16. Negative 16 plus 24 is 8. 8 is choice A. And of course, you might notice that like this is the exact same as that, and there is obviously a reason for that. The reason is because 4 or negative 4, if you square them, you get the same thing, right? So you can notice that let me just erase this for a second. If you can notice that in this original equation or function up here, this is what we call an even function, because every single term has an even degree. This is a degree 2, x squared. This is a degree 0, no x's. If this is even, that means that it's going to be the same for x and negative x. For 4 and negative 4, for 3 and negative 3, it's going to be the same. So we know that if 4 is going to be 8, then we can just find negative 4. It's an even function, so it's still going to be 8. That's just a pretty quick method that works for this solution, that works for this method. On the SAT in general, they will give you problems that you can apply a lot of these kind of tricks in, right? SAT is full of these, but of course there always is just the tried and true method, works every time method of just going in it, bashing it out. But with that, let's go to question number 11. Question number 11 is right here. All right, so question number 11. B equals 2.35 plus 0.25x. 0.25x. And C equals 1.75 plus 0.40x. Okay. So what are we told? We're told in the equations above, these equations, B and C represent the price per pound in dollars of beef and chicken. So beef and chicken. Respectively, X weeks after July 1st during the last summer. So what was the price per pound of beef when it was equal to the price per pound of chicken? So this is the price per pound of beef, and this is the price per pound of chicken. And we're asked, what is B and C when they were the same? So we're just trying to find what is B or C when B equals C, right? But we can just set these two equal because this is a function in one variable at that point. Right, one variable, constant variable. That's it. So you get 2.35 plus 0.25x, and that's going to be equal to 1.75 plus 0.40x. Okay? Now at this point, you can subtract 1.75 from both sides, 0.6, and then you subtract 0.25x from both sides, and you get 0.15x. You divide both sides by 0.15, and you get 4 equals x. And then you want to find your B or C, right? So, like if you plug x equals 4 back in here, that's going to be 2.35 plus 1. That's just going to be 3.35. $3.35. And same thing here, you can still plug this in. You get 1.6, 1.75, that gives you 3.35. Obviously, they're the same when this happens, so they're going to give you the same thing, obviously. And our answer is 3.35. Our answer is choice D. Choice D. 11 is D. Okay. And we can keep going to the next question. Alright, so the next question, number 12. A line in the xy plane passes through the origin and has a slope of 1/7. Which of the following points lies on the line? So it passes through the origin, right? So it passes through 1/7. It passes through 0, 0. So if you're gonna write this in y equals mx plus b form, all right, so 0, 0. That's going to give you 0 equals 0 here, so that's just going to be 0, plus b. Now, this seems like a really obvious equation, and just b is 0, right? Anyone looking at this, b is just 0. Right? That's just 0. We can just get rid of that. We just get rid of that. Y equals mx. That is all we have. And we're given that m is 1/7, so we can just get rid of this and say, put a 1/7 here. Y equals 1/7 x. That is the equation of that line they're talking about. Now, one of the points that they're talking about has to be on this line. Now, you can either just like plug in all the points and see what happens, or you can just you can notice that like I can just multiply both sides by 7 and get 7y equals x. So I want an x coordinate that's 7 times my y coordinate. And I see that choice D has an x coordinate that's 7 times my y coordinate. Has 14, 2. So obviously if I plug in 14 here, I get 2 here. So it works. 14, 2 is our answer, and just we get choice D twice in a row. Alright. That was a fumble D. Choice D. And we move on to question. Oh, I have to go on the next page. Question number 13. Let's zoom out a little bit. If x is greater than 3, which of the following is equivalent to 1 over 1 plus x over 2 plus 1 over x plus 3? Wow, look at that. Okay, what do we have here? Okay, so what we have is 1 over that mess. Alright, now the thing we can do here is we want to find in that 1 over x plus 2 plus 1 over x plus 3, we want to make that have a common denominator, right? So we can make the denominator x plus 2 times x plus 3, right? So we multiply the first fraction by x plus 3, and we get x plus 3 over this. The second fraction we multiply by x plus 2 over this, and that's it. Now this is in the denominator of the denominator, so it goes in the numerator. So this becomes x plus 2 times x plus 3 over x plus 3 plus x plus 2, which is just going to be 2x plus 5. Now x plus 2 times x plus 3 is just x squared plus 5x plus 6 if you just FOIL it out. X squared plus 5x plus 6 over 2x plus 5. That is choice B. Choice B. And we can keep going to question number 14. Let's go. All right, question number 14. Scroll down to that. If 3x minus y equals 12, what is the value of 8 to the x over 2 to the y? Okay, this seems like an interesting problem. So on the face of it, you look at this, and you look at this, and it's probably you're just like really confused at this point, like what is going on? Like why does this tell me anything about that? But let us break this down. So we know that 8 is 2 to the 3. So 2 to the 3 to the x over 2 to the y. Now if you remember our exponent rules, we know that 2 to the 3 to the x is just 2 to the 3x. This is 2 to the 3x over 2 to the y. And you know that, again, exponent rules, 2 to the 3x over 2 to the y is going to be equal to 2 to the 3x minus y. 2 to the 3x minus y. But 3x minus y is 12, so this is just 2 to the 12. All right, 2 to the 12, answer choice A. So number 14 is A. And we can go on to the next question. So about this question number 14 right here, it seems it's a pretty ingenious question, right? So we started off with this, they gave us this, and we just have to use our exponent rules to figure this out. You could have like found what y was by like y is 3x minus 12 or something, but you don't have to. You can just use these rules. So these rules are extremely useful, so you should probably memorize them, right? They aren't that hard to memorize. They're pretty basic, so yeah, you should just memorize them. They're pretty useful. All right, next question. 15 if ax plus 2 times bx plus 7 equals 15, x squared plus cx plus 14 for all values of a, and a plus b is 8. What are the two possible values for c? Okay, so ax plus 2 times bx plus 7. If I FOIL that out, I get abx squared plus 7a plus 2b times x plus 14. Okay, so what do I get? I get that AB equals 15. And I get that 7A plus 2B equals C. And then they're telling me that A plus B is also, A plus B is 8. A plus B is 8. All right, now what can we do with this? So you can probably find the first value for A and B, right? Which is just 3 and 5, right? I mean, 3 and 5 is 8, and 3 times 5 is 15. And then you notice that this is addition. Addition is commutative. You can what am I saying? You can swap them around or switch them, and you'll end up with the same thing. You can do the same thing up here, and you're still gonna end up with 15. So you can just 5 and 3, 3 and 5, 5 and 3. Both of these both work in both cases. All right, now we gotta plug this into here. 7 times 3 is 21. 2 times 5 is 10. So the first value is going to be 31. 31. And then we plug in 5 as A and 3 as B. 35 plus 6, and we get 41. 41 for that. So 31 and 41. 31 and 41 is choice D. Choice D. And that is question number 15. We can move on. All right. Very interesting question. And let's go to the 16. All right. So here, as you can see, we are getting into the gridded responses. All right. Now, the thing about graded responses is that like people seem afraid of them, which I kind of get because you're not given choices. So like you can't just like you can just plug in the choices and see which one works because sometimes that is a strategy that works. Now, the thing about graded response problems is that since they know that people freak out about it, they're actually usually easier. They're like usually easier than the general problem on the SAT. Like this one right here. If t is bigger than 0 and t squared minus 4 is 0, what is t? And I don't know, like, you can just add 4 to both sides. Just that's the first thing. You can add 4 to both sides. And then you take the square root of t, of both sides, and you get t equals 2 or negative 2. And you're told that t is bigger than 0, so t is 2. That's it, like, I told you. Right? Like, these problems, since people freak out about them, the SAT or College Board, whoever makes these tests wants to make them easier, right? So they are going to they're easier questions. So please don't freak out about them. So 16 is just two. It's two. All right, let's go to the next question. Right, don't freak out about the drawing. No, that's the whole question. You can just look at this. A summer camp counselor wants to find a length x in feet across a lake as represented in the sketch above. The lengths represented by AB, EB, BD, and CD on the sketch were determined to be those values. So before we get started, we should probably just draw the diagram out, right? So draw this here. No, that's too long. And then here. Okay, well now my drawing is just inaccurate, but hey, it looks close to what is being drawn there. Okay, so if we have this drawn, right, we have this drawn. AB is going to be 1,800 feet, so probably should label this actually first. A, B, C, D, E. So AB is 1,800. EB is going to be 1,400. EB is 1,400. BD is 700. And CD is 800 feet. And segments A, C, and D intersect at E, or AC and DE intersect at B, and AEB is the same as EDC. Is that right? Yeah. Okay, so trying to find X right here. So one thing that is kind of a continual annoyance for like every single high school student ever in math is triangles. Because triangles have a lot of things you can do with them, and it's kind of hard to remember all of them. One of the most important things you can do with triangles is using similar triangles, using ratios. Right? So now, if I want to get some similar triangles out of this, what would I do? So I know that this and this are going to be the same. They're called vertical angles. Even though they're horizontal, but they're called vertical angles. So I know that these two angles are the same, which I know that since all three angles add up to 180, this angle is going to be the same as that angle. So if all three angles are the same, then you have a similar triangle, which means that the ratios of these sides to the ratios of these sides are constant. Right? So essentially what you can think about it as is, right, is if I took this triangle right here, this BDC, and like rotated it so that this angle was like at the bottom and then this angle was like to the side, then I would end up with just a smaller version of that. That's all that means. That similarity means. That's all we're doing here. Okay, so how do we actually go about finding x in this situation? So, like we said, right, we can like turn this around, flip this around, or something, right? So we can also just like it's very useful to label all the angles because now we can label the angles like this. Now we can label the sides like this. Sorry. So the side that's in between the 2 and the 1 is BD. BD. And that's going to be similar, and that with that ratio, to the other side in between the 2 and the 1. EB, or BE. Now that's 700 over 1400, which is 1/2. Okay, now the between the 2 and the 1 over the between the 2 and the 1, that's the ratio. Now, this ratio is going to be the same, since it's similar triangles, to, say, between 2 and 3 here, and between 2 and 3 here. But what we can do is we want to find that length. So we can do between 1 and 3, sorry, we can do between 1 and 3, this is between 1 and 3, between 1 and 3, DC, or CD, between 1 and 3, AE, you can set that up. And this is just 800 over AE, over X. So if 1/2 equals 800 over X, then you can solve this pretty quickly and realize that X is 1600. X is 1600. Alright, so 17,1600. Alright, so that problem did look a bit scary. Once you understand what's going on with the angles, right, once you understand how to manipulate the triangles and just set up the ratios, it turns into a pretty easy computational problem. Okay. Let's go question number 18. Alright, so now we have x plus y equals -9. X plus 2y equals -25. And we're trying to find x. We're trying to find x here. So one of the obvious things I can do is let's do the second equation minus the first equation. Because that way, this and this cancel out, right? And then we get 2y minus y, which is y. And we get -25 minus the -9, so -25 plus 9, -16. And now we can find x. And it's not really that hard to realize that x minus 16 is -9 now. So x is going to be 7. X is going to be 7. X equals 7, and that is our answer. X is 7, and that is our answer. Okay, so now we're going to the next question, or it's already there really, so I can just leave it like that. In a right triangle. Alright, so we're going to deal with right triangles. In a right triangle, one angle measures, what does that say, x degrees, where sine x degrees equals 4/5. What is cosine 90 minus x degrees? Okay, so if you have this, something like a formula memorized for trigonometry, you might realize that, you can just say sine x equals cosine of 90 minus x, in degrees, obviously. So sine x equals 4/5, so cosine 90 minus x is also going to be equal to 4/5. Now, this is a pretty basic relationship that you should learn in trigonometry. Hopefully you learned it. But if you didn't, never fear, because there is a very easy way to figure it out. Alright, so it's a right triangle, right? We're dealing with a right triangle, so I'm just going to draw a right triangle. Let's draw a right triangle. Okay, so this is that one, this is x, and this is, since they have to add up to 180, this angle right here is going to be 90 minus x. Right, and now we have sine of x, right, which is going to be this opposite over hypotenuse. Sine of x, this over this, is 4/5. We can just say 4 and 5. Sine of x is 4 over 5. Easy. And now we're trying to find cosine of 90 minus x. So cosine of this right here, which is, cosine is adjacent over hypotenuse. Adjacent to this is here, hypotenuse is here, 4 over 5. 4 over 5 is our answer. So, in a lot of SAT questions, as I said before, there are a lot of ways that you can apply tricks and stuff. But if you don't know the trick, if you don't see the trick immediately, you can always just bash it out. In this question, we just drew the triangle, and that was basically it. Alright, Last question on this section. A equals 5 times the square root of 2, and 2a equals the square root of 2x. And we want to find x. Okay, so the first thing I see here is that 2a equals something x. So we want to find x, we want to find 2a. And we can just take this and multiply it by 2 times 2, and then this times 2 is going to be 10. 2a equals that. Done. 10 times the square root of 2 is going to equal 2a, equals 2a, equals that. So equals the square root of 2x. Then I'm going to square the whole thing. 100 squared times 2 times square root of 2 squared is going to be 200, and that equals 2x. Because you square this, you get the square root, and x equals 100. X equals 100. Okay, so that was question 20, and I'll also erase this. Alright, so that was the graded response question. That was every question on this SAT math no calculator test. If you're wondering where we got this test from, it's SAT Practice Test 1 on Khan Academy, as well as the official College Board website. Try it out if you want to. It's very good practice, both the non-calculator and the calculator sections, as well as the other two reading and writing sections. We will be doing a video on the calculator section of this math portion in the next video, and reading and writing will be coming soon after, so stay tuned for that. I'll see you then.